solve an equation with fractions by writing it in quadratic form. Here we have an equation that involves fraction. There are a few things you want to note here. When you see a variable at the bottom of the fraction, you want to make a note that x minus 1 cannot be equal to 0, because that would make that undefined. So x in this case cannot be equal to 1. And also we have an x here at the bottom of the fraction. X also cannot be equal to 0. So these are the two restrictions we have. If you find any of these solutions, we want to exclude them as part of our final answer. So in this case, every time you see equations involving fractions, the first thing you do, you look for LCD. So in this case, if I make this also 9 over 1, you can see the LCD among x minus 1, 1, and x is x times x minus 1. The method here is to multiply each term by this LCD. So here we have 1, 2, 3 terms. So I'm going to multiply each term by x times x minus 1. So in this case, if I distribute this, x minus 1 reduces. First term would have 4 times x right here. If I distribute x times x minus 1 with the second term, I would get 9x times x minus 1. And finally, if I multiply the LCD by this last term here, x over x would turn to 1. So you would get minus 7 times x minus 1. So by multiplying each term by LCD, we eliminate the fractions and we get it into a linear equation here, where we all know how to solve now. If I go ahead and distribute 9x, I would get 4x plus 9x to the power of 2 minus 9x equal to minus 7x plus 1. And then we just simply solve this by moving all the terms to one side of the equation, let it equal to 0, by adding 7x and subtracting 7 from both sides of the equation. And then we would factor this, assuming everybody knows how to factor this already. If you have a problem with factoring, you want to go back and review my sessions on factoring. And then you let each of these parentheses equal to 0 and solve for x. You want to note here that once again, x cannot be equal to 1, x cannot be equal to 0. We check our answers. We don't see any of those. You can always check our answer by substituting each of these numbers into the original equation and confirm that.